Hi everyone, welcome back to our channel. Today we are going to discuss about the lecture 27, that is Laplace transforms of standard test signals. Okay, so here the standard test signals are given here. So let us try to discuss what are the standard test signals. First test signal is step function. Okay, so how to define this step function and how to find the Laplace of this step function we will discuss now. Okay, so step function is generally written as a u of t that maintains a magnitude of 1 for t greater than or equal to 0. Okay, or it maintains a value of 0 for t less than 0. Okay, now I'm going to define the test signal. In the x-axis I'm going to have t, and in the y-axis I'm going to have u of t, and you can see the signal, it is available here. So this is the test signal. The red color one what I'm drawing is an test signal. So it is like this. Okay, it maintains a magnitude of 0 for a time t less than 0, and at a time t equal to 0 and t greater than 0, and again it maintains a magnitude of 1. Okay, so this is like a step. How you have staircase in your home, it maintains initially 0 value and then it maintains 1. Therefore these sort of signals are called as a step signals or step function. So this is defined with a name u of t. So now for this we need to find the Laplace transform. Okay, we have the Laplace transform of f of t. Okay, Laplace transform of f of t we can write down as this is integral 0 to infinity. What is this f of t defined as? Which is nothing but u of t. So this is also, you can write directly u of t. Laplace of u of t is equal to u of t e to the power minus st into dt. So this you can write down it as integral of 0 to infinity, and this is the Laplace of f of t, or here we are defining this f of t as u of t, where this is called step function. Laplace of u of t is equal to, it maintains a value of 1 into e to the power minus st dt. So you will ask, sir, how to write down the remaining? If you write down the remaining from minus infinity to 0, this value is 0. Since this value is 0, automatically there's no need to define it. This is how to write down Laplace of u of t. So then we are going to get, so try to perform integration. So already we know the formula, integral of e to the power ax into dx is equal to e to the power ax into 1 by a into 1, which is nothing but 1 by a into e to the power ax is the formula. Apply this integration here also. Okay, so therefore you are going to get e to the power minus st, and integral values are varying from 0 to infinity. So you 1 by e to the power minus st multiplied, I mean it is divided by 1 by minus s into 1. Okay, so now this minus 1 by s I am taking common, then I am going to get e to the power minus st, the integral values varying from 0 to infinity. So this I can write down it as a minus 1 by s into, so this I am going to write e to the power minus, so t we have to substitute as infinity and 0, e to the power minus s into infinity minus e to the power minus s into 0. So this we can write down it as minus 1 by s into, this I can write down it as 1 by e to the power infinity minus 1 by e to the power 0. So this I can write down it as minus 1 by s into, so 1 by infinity is nothing but 0. This is minus 1 by e to the power 0 is nothing but what? 1. So this is minus 1 into 1. So minus into minus is plus 1 by s. So the Laplace transform of a step function, which is nothing but u of s is equal to 1 by s. Okay, so these signals are very important when you understand the standard test signal. So this is how to write down the standard test signal. Under this first test signal is step function. Okay, this is how to define. So let's try to write down. So u of step signal, u of t is equal to 1. So u of s, you are going to get it as a 1 by s square. Basically you have the formula like this. So that like nothing but Laplace of constant is equal to k by s, or Laplace of constant equal to 1 by s, or Laplace of k into dt, we are going to get it as k by s. This is how to understand the Laplace of an standard test signals is 1 by s. Okay, now this is all about defining an step function. Let's try to define the next function in the upcoming class. Okay, so let's try to go to the next function. So second one is unit ramp signal, or how to define a ramp signal. So ramp signal can be defined as R of t. Okay, so R of t, and the ramp signal will be like this. Okay, in the x-axis you are going to have t, and in the y-axis you are going to have f of t. Okay, so here this f of t we are writing as the function r of t. So, and it is a straight line which is flowing and maintaining a slope m is equal to 1. The equation for slope y is equal to m into x. So what is the value of y? Y value is r of t is equal to slope is 1, x-axis is nothing but what? T. Therefore r of t is equal to t. Okay, so this is the value for t value greater than 0, and similarly at t equal to 0, and it maintains a value of 0 for t less than or equal to 0. So this signal I am writing it as a r of t is equal to, it maintains a value of t for t greater than or equal to 0, and it maintains a value of 0 for t less than 0. Okay, so this is the r of t. For this we need to find out the Laplace transform. See that we are going to get r of s, that value should be 1 by s square. So this is what the value we are supposed to get. So now let's try to use the basics. Okay, so now I am going to perform Laplace of r of t. So Laplace of r of t I am going to define from a lower integral of 0 to infinity into r of t e to the power minus st into dt. Okay, so that value is equal to integral 0 to infinity. So this I am not writing. Why? Because plus 0 I have to write down. This only for t greater than 0 I am writing. So varying from 0 to infinity, t into e to the power minus st into dt. Okay, so if you perform the integration, so the formula for integration we are having is integral of uv dx is equal to u integral of my integral of v dx minus integral of du by dx into integral of v dx totally. Again, this is the total integral term. Okay, so when you do it, so here we are going to get first term is this one. Okay, so this is u. What is the value? This is u value and this is v value. It's nothing but t into integral of 0 to infinity. So e to the power minus st into dt is the first term, and this is the second term. So this I am going to write down it as minus integral of 0 to infinity. So differentiation of dt by dt is nothing but how much? 1. Okay, so 1 into integral of vdx is e to the power minus st into dt. So this is what we are going to get. So now, so first we'll try to perform the integration for this term. Okay, so this, if you substitute here, so this is infinity. Okay, so this value only I'm doing. So this value, if you do it, this is nothing but t into e to the power minus st. Okay, so already we have defined integral of e to the power ax into dx is equal to e to the power ax into 1 by a. So the integral of this term we are going to get it as t into e to the power minus st divided by minus s, varying the limits from 0 to infinity. Here also integral 0 to infinity e to the power minus st. So this is nothing but 1 by minus s. Okay, so and these are the terms. So when you write down these integral terms, we are going to get infinity e to the power minus infinity with a whole term of minus 1 by s, infinity minus e to the power minus infinity, minus 0 into e to the power minus 0, minus of, again the integration we have to do it, which is common term is minus 1 by s, and integral of this term is e to the power minus st multiplied with 1 by, so e to the power ax into 1 by a. Here it is nothing but minus 1 by s. Okay, so the overall term we are going to get it as minus 1 by s. This is infinity into e to the power infinity minus 0 divided by e to the power 0 minus, so this minus into this minus, please plus 1 by s square into e to the power minus st, and the limits are here varying from 0 to infinity. So this is from 0 to infinity. So when you substitute here all the limits, so minus 1 by s, this is infinity is nothing but infinity minus 0. Okay, so 1 by infinity is once again 0. This total term will become 0. 1 by minus 1 by s square into, so this I can write down it as 1 by e to the power infinity minus 1 by e to the power 0. This I can write down minus 1 by s square. So 1 by infinity is how much? 0, minus 1 by 1 is how much? Minus 1. So therefore it's nothing but minus into minus, we are going to get it as 1 by s square. Okay, so that is what you have to remember. The Laplace transform of an unit ramp signal is 1 by s square. Okay, so this is time domain equation, this is the frequency domain equation, this is r of t equal to t and r of s is equal to 1 by s square. So this is the derivation to find out by using the basic formula integral of uv dx, which is nothing but called as integration by parts. Let us try to see the next standard text signal, which is nothing but a impulse function. Okay, so next one is impulse function. So third text signal is impulse function. So impulse function is defined it as delta of t, and it maintains a value of 1 for only t equal to 0, and it maintains a value of 0 other than t not equal to 0. Now the signal I am going to define here. On the x-axis I am going to have time, on the y-axis I am going to have f of t, and now you can see here it maintains the magnitude of 1. Okay, so the magnitude of 1 means, you can see here, so this red color one what I am showing, it maintains a magnitude of only 1 at t equal to 0. Whenever t value is greater than 0, this is 0, and whenever t value is less than 0 also, it maintains a value of 0. At t equal to 0 only, it maintains a value of 1. Therefore this f of t is called as a delta of t, where delta of t is nothing but the impulse function. F of t is indirectly also delta of t only. Okay, so f of t I can write down it as delta of t. Okay, now for this we need to perform. Okay, so the Laplace transform, when you perform, you are supposed to get the Laplace of delta of t. You need to get the value as 1. So how to do it? Let us try to understand. Okay, so this delta of t I can write down it as so I can get three signals. The first signal is impulse next signal is step, next signal is ramp. Okay, so by differentiating the step signal, I can get impulse signal by differentiating an step signal. So how to write down the step? This signal I can write down it as delta of t. Already we discussed. This signal we can write down it as u of t, and this signal we can write down it as a ramp signal r of t. So now we require the step signal is u of t. So I can write down the impulse signal is d by dt of u of t. Okay, I can write down. Okay, this is how to write down an impulse signal. So now I want the Laplace of delta of t, which is nothing but I require the Laplace transform of this one, which is equal to, so this is Laplace of d by dt into u of t. Already we know that simple Laplace of differentiation is s into f of s. I mean s into f of s. That f of s is nothing but d by dt into u of t. So now s into what is Laplace of u of t? Already we have been done it. So sorry. Okay, sorry. Small. This is Laplace of d by dt into f of t, we are going to get it as s into f of s minus f of 0 minus. Actually, this value at time t equal to infinity will consider it as 0. So now from here you can get this value as s into Laplace of u of t. Okay, minus this initial value we are going to get as u of 0 minus we are going to get it as 0. So this I can write down it as s into what is Laplace of u of t? Laplace of step signal is 1 by s. S will get cancelled and you are going to get the signal as 1. So therefore, now we had studied the impulse signal is delta of t. The impulse signal is delta of t equal to 1 and the Laplace transform value is 1. Okay, and already we studied the Laplace transform of ramp signal. So this is an ramp signal. The Laplace transform for this is 1 by s square. Okay, and now already we studied the basic step signal. The Laplace of step signal is 1 by s. Okay, let's try to revise the things in a clear fashion. So we already know step signal. So step signal I can write down it as u of t, okay, and is equal to 1. The Laplace of step signal we are going to get it as 1 by s. Next one is we are having an ramp signal. Okay, the ramp signal I'm going to define it as r of t is equal to t. The Laplace of r of t we are going to get it as 1 by s square. Okay, and next you have an impulse signal where this is nothing but called as delta of t is equal to d by dt of a step signal. This Laplace transform of impulse signal you are going to get it as 1. Okay, so this is the relationship between how a step signal, ramp signal and impulse signal will be generally existing. So these three signals are called as standard test signals that we can apply to any kind of network to find the output. If you feel my explanation is good, please like the video and share the video with your friends. And if you have any doubts in the signal, let me know in the comment section. And if you are watching the channel for the first time, subscribe to my channel with the name kvthulasi. Thank you for watching patiently. We'll meet in the another video. Thank you.